Hello, my name is Scott Grizzard from the University of South Florida. This is Calculus 1. This is a supplement to Lecture 8B, more triangle trick problems. I tried to do this during the day, and I absolutely messed it up the first time I did it on Twitch, so I'm re-recording it so that it's a little less embarrassing and so that it's nice and clean and it doesn't have a bunch of other stuff in it. So what I want to do is I want to solve these three triangle problems. And as you can see, I've already, so these are inverse trig problems. They're kind of a pre-calc refresher. And they all basically have this little triangle trick. So I picked three of them up. And all of them kind of do the same thing. What I'm going to do is I'm going to let whatever's in the arc bit, or the sine -1 bit, or all these other things, I'm going to let that be theta. All right? And then what I'm going to do is I'm going to go backwards. So arctan, remember that like arctan, arcsine, all of these things, they take angle. They take sides and they make angles. All right? So let's start with this one. So I'm going to let theta here equal arcsine. Okay. So let of arcsine. So let theta equal arcsine of x. Now note I'm going to take the sine of both sides, and that's going to be then sine of theta equals x. Okay. So my tangent of arcsine is going to be the tangent of theta. Now, I have these little, remember this SOHCAHTOA stuff, right? Sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over adjacent. And here what I have is the tangent. So I'm going to draw a little triangle. And note that here I want the tangent of something. But look what I have. I have that the sine of theta equals x, right? Because I let theta equal the arcsine. So I'm going to write that right here. I'm just going to bring this down a little bit here. And this is kind of the key. So what I have here, if I let sine is opposite over hypotenuse, right? So here's opposite, here's hypotenuse, and here is adjacent. So what I'm going to do is I'm going to let, I have this and I want this. So what I'm going to do is I'm going to let sine, I'm going to let the hypotenuse, since that's on the bottom of what I have, be 1. And if I do that, then this side here becomes the sine of theta. Here's theta in the bottom, which equals x. And now what I want is I want this side, the opposite, over the adjacent. Want opposite over adjacent. So what I need to do is I need to solve for the adjacent. So I've got 1 squared plus I've got 1 squared equals x squared plus whatever the adjacent is. All right, and that's what I want to solve for. So I'm going to move x to the other side, and I wind up with the adjacent squared equals, this is 1 squared is, of course, 1 minus x squared. So that means that the adjacent equals the square root of 1 minus x squared. So now I'm just going to go, okay, well, this right here is the square root of 1 minus x squared. And what I want is tangent. Well, tangent is opposite over adjacent. So I take the opposite x and I put it over this. And I get that this equals the x over the square root of 1 minus x squared. Okay. Let's do another one. This time the tan is here. Here's the sine. So what I'm going to do, I wind up with that the theta equals arctan. So tangent of theta equals x, which is the opposite over adjacent. So the adjacent, what I have, the adjacent is the bottom of what I have. So what I'm going to do is I'm going to let that be 1. Then what I'm going to do, then of course that means the opposite becomes x. And now I'm just going to solve for the hypotenuse. I did that right here. So the hypotenuse squared equals 1 squared plus x squared, meaning the hypotenuse equals the square root of 1 plus x squared. And I get that there. Now what I wanted was sine. Sine was the opposite over the hypotenuse. So I wind up with x over the square root of 1 plus x squared. And that's my answer. This one's a little bit more tricky. Here I've got a 2 in the thing. So what I'm going to wind up with is I'm going to let this bit be theta. Let's move this over to the side here for a moment. Let's just erase it. So theta now equals the arctan of x. So I'm going to let this bit here be theta. So what I wind up with is cosine of 2 theta. All right, well, what I'm going to do is I'm going to apply the double angle formula. I need to get that 2 out. So what I'm going to have then is I'm going to have cosine squared of x minus sine squared of x. And if you look down here, there's these cool little triangle mnemonics that you could use to memorize these things, if you don't remember. So if I have here theta, theta, I have these 2 weird little triangle things. That means that this angle right here is twice theta, right? Because this bit here, this triangle here, and this triangle here form, opposites. That makes this, so if I flip the image around, right, the adjacent to this angle is this side, the opposite to this side is this side. This thing right here was 1. So I wind up with the cosine of 2 theta, which is this distance here. This distance here, this right here is theta, because this is a triangle that is similar to this triangle. So this is theta right here. That means that for this thing here, I wind up, since this is my hypotenuse, this right here, when I do the math, is going to come out to sine theta cosine theta, and this right here comes out to sine squared theta. All right. Oh, and by the way, this and this are equal. So those are easier to solve for. Okay. So what I wind up with here and here, what I wind up here is with cosine of 2 theta equals cosine squared minus that piece. And if you don't remember the mnemonic, that's okay. You just remember the double angle formula. Okay. Those should be of theta, not x. All right, so now what I have is the tangent, and I want the cosine and the sine. Okay, so tangent is x, so I'm going to say that this is x and that's 1. Now my hypotenuse I need to solve for, so the hypotenuse squared equals 1 squared plus x squared, which means that the hypotenuse is going to equal the square root of 1 plus x squared. Okay. So now what I'm going to do is I'm going to solve for cosine of squared and sine squared, okay? So cosine equals the adjacent over the hypotenuse. So cosine of theta equals the adjacent 1 over the hypotenuse, the square root of 1 plus x squared, which means that cosine squared of theta equals 1 squared over the bottom here, which was 1 plus x squared. Sine, on the other hand, equals the opposite over the hypotenuse. So sine of theta, not son, sine of theta equals x over that whole business again. So sine squared of theta equals x over 1 plus x squared. And look at that. They even come in a common denominator for me. I love that. So what I'm going to wind up with, I'll do this in a different color. So what I'm going to wind up with is 1 over 1 plus x squared minus x over 1 plus x squared, which of course equals 1 minus x over 1 plus x squared. Of course, that can't factor. It factors into complex numbers, not regular numbers. And I'm done. So I have 3 examples of this triangle trick, right? I have a straight triangle where I'm doing a tangent. I have this one, and then I have this weird one where I've got some extra step where I have to use the double angle formula. Now, the key thing here was whatever was inside this, I made theta. So what are the key points? Whatever is in the arc, make theta, and then do some SOHCAHTOA. Okay. All right, and that's that should be sum. There we go. And then do some SOHCAHTOA. Okay, so that's it for the triangle trick. Thank you for watching.